Happy morning, guys. Today we shall see one important part in deep block elements, that is enthalpy of atomization or heat of atomization. So enthalpy, the word enthalpy itself, what do you mean by the word enthalpy? Heat change. The heat change that takes place during the atomization. What is atomization? Atomization is nothing but making into atoms. Atomization nothing but making into atoms. That is breaking into atoms. So the enthalpy change when a compound bonds are broken and the component atoms are reduced to individual ions. So the energy change takes place when a compound is broken. The bonds of the compound are broken and it has been made into atoms. Let us consider an example. Consider this as a solid. Consider this as a solid, that is iron. So iron is in Fe2 plus form here. That is, these are the iron atoms arranged inside the solid. Fe2 plus, right? It is in the 2 plus form, right? Okay. Now, the electron, released by the iron, this one, Fe2 plus, every atom gives 2 electrons to make the bonding here. So those electrons are free and they will be moving in between like this, right? So wherever the spaces are available, the electrons are free to move like this in between the spaces, right? So like this, wherever the spaces are available, the electrons are freely moving inside the spaces between the atoms, iron atoms. So here, the iron is positive and this electron cloud is negative. So there is force of attraction between the positive and negative, right? Between the positive and negative. So if I have to take this iron atom out, so what I have to do? I have to provide energy. I have to provide energy enough to break the force of attraction between these positive and negative, right? So if I have to take this iron atom out, I have to provide energy to break the force between the positive and negative side here, positive and negative charges here. That force is called, that energy is called, or the energy change takes place during the process is called enthalpy of atomization. That is called the enthalpy of atomization. Got it? So the attraction between the positive and negative part gives rise to metallic bond. Yes. And if I have to create atoms, I have to supply energy to break this metallic bond, right? So that energy change, that del H, that is equal to enthalpy of atomization. That del H is equal to enthalpy of atomization. So simply we can say that the energy change that happens during the breaking of metallic bond during the process of atomization is called the enthalpy of atomization or heat of atomization, right? Okay, so now it has been clear, that is enthalpy of atomization is clear for you. Now let us check into let us see this later. Okay, let us come to this part later. Right. So enthalpy of atomization is clear for you. Now Let us check out the enthalpy of atomization in 3D series. Enthalpy of atomization in 3D series. Right? Let us write the 3D series first. That is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. That is atomic number is here 21. 2, 3, 4, 5, 6, 7, 8, 9, and 30. Let us write the configuration here. That is easy. I think you know that it is 3D 1 to 10 or n minus d 1 to 10. We can go for n minus d. That is n minus 1, 1 to d and ns 1 to 2. So here it will be 3d1 4s2. No need to write the 4s2 because all the elements are the 4s2. So here 3d1, 3d2, 3d3, here 3d5, 4s1. Here 3d5, 4s2, and here again 3d 4, 3d 3, 3d 2, 3d 1, and here the d orbital has been completely filled. So that is the number of unpaired electrons is 0. The number of unpaired electrons is, so this is number of unpaired electrons. So number of unpaired electrons. Right. Okay. Now let us have a look into that. The enthalpy of atomization is directly related to MP and dP. The enthalpy of atomization is directly related to melting point and boiling point. Right? Now, so many of you are confusing. Many of you are confusing between the melting point and heat of atomization or enthalpy of atomization. Right. First of all, let me clarify that. Melting point. What is melting point? Melting point means solid. When a solid changes into a liquid at a particular point. So that is called melting point. So what is enthalpy of atomization? Enthalpy of atomization is solid. It changes into gas. It changes into atoms. It changes into gas. And the melting point is directly related to number of unpaired electrons. The melting point is directly related to number of unpaired electrons, right? That is, more the unpaired electron, more the unpaired electron, more the unpaired electron, more the MP, right? So the number of unpaired electrons directly influences the melting point. So here, that is why I had gone for the electrons, number of unpaired electrons here. So let me change the brush size so that it is, I feel that it is too heavy. So that let me change the brush size and color too. Okay. Right. So the number of unpaired electrons, more the number of unpaired electrons, more the number of unpaired electrons, more the melting point. right? Now, here, which is among the 3D series, which is having the more number of unpaired electrons here? Yeah, here, chromium. This chromium is having the more number of unpaired electrons. How many number of unpaired electrons? 3D 5, 5 in D and 1 in S orbital. So, this is having 6 number of unpaired electrons. The manganese is having 5 number of unpaired electrons. So, the rest are all very low, right? And the vanadium is having 3 unpaired electrons, right? Okay. So what people will do when comparing the enthalpy of atomization, they will say that chromium has a more number of unpaired electrons, so that chromium is having the high enthalpy of atomization. Chromium, so it has more number of unpaired electrons. So it leads to more enthalpy of atomization, more enthalpy of atomization. But this is not true at all. More number of unpaired electrons. Chromium is having the more number of unpaired electrons. I accept that. Chromium is having the 6 unpaired electrons. I accept that. But the enthalpy of atomization for chromium is not like this. So let me write here chromium, that is 3D 5 4s1. The number of unpaired electrons n is equal to 6, right? And here vanadium, that is 3D 3 4s2. So the number of unpaired electrons n is equal to 3. The boiling point of chromium, that is next point, the BP of chromium, the boiling point of chromium is 2700 degrees Celsius, and the boiling point of vanadium, is 3407 degrees Celsius. 3407 degrees Celsius. Right. So, what is enthalpy of atomization actually? Enthalpy of atomization means in melting point, just we are changing solid to liquid. Just we are changing solid to liquid. But in atomization, what we are doing, we are converting solid to liquid and to gas, right? So the BP plays an important role here. That's why the boiling point of vanadium is more higher than the boiling point of chromium, right? So that this vanadium requires more enthalpy of atomization. Del H will be more for atomization in the case of vanadium than the chromium. Is that clear? That is, del H will be the enthalpy of atomization is more for vanadium. So finally, we can write the words like this. That is, enthalpy of atomization. Enthalpy of atomization is more for vanadium than chromium due to high boiling point of vanadium.